Catalyst is a foreign substance which takes part in a chemical reaction, alters the rate of reaction, remains unaffected at the end of reaction. Two types of catalysis, homogeneous catalysis and heterogeneous catalysis. Homogeneous catalysis is the one where the reactant, catalyst and products all three are in the same phase. For example, 2SO2 plus O2 in presence of nitric oxide as a catalyst to give 2SO3 in the preparation of sulfuric acid by contact process, all are in the same phase, that is said to be gaseous phase. Second example, that is C12H22O11, that is said to be sucrose, reacts with water H2O in presence of acid catalysis H+, it gives C6H12O6 glucose, C6H12O6 fructose, having the same molecular formulae, all are said to be in the liquid state. Heterogeneous catalysis is the one where the reactant, catalyst and product are in different phases. We can take a best example of N2 plus 3H2 equal to 2NH3, iron as a catalyst, molybdenum as a promoter. Here the reactants and products are in gaseous state, whereas the catalyst is in solid state. Autocatalysis. Autocatalysts are those in which case one of the reaction product itself becomes a catalyst. It catalyzes the reaction. The best example is titration of oxalic acid with potassium permanganate in presence of sulfuric acid. Here, sulfuric acid provides the acidic medium. In this case, oxalic acid is oxidized to carbon dioxide and potassium permanganate MnO4 minus is reduced to Mn plus 2 as MnSO4. So, Mn plus 2, that is MnSO4, actually catalyzes the reaction. Here, the magnet color is purple in color. As the titration goes on, more and more manganese sulfate is produced. At the end point, it becomes colorless. So, color changes from purple to colorless. So, KMnO4 is a self-indicator. Here, in this case, no indicator is added from outside. The MnSO4 produced the Mn plus 2 ion itself catalyzes the reaction, means it fades the purple color to colorless. Not only that, there are catalytic poison. In some of the cases, small amount of presence of a foreign substance, it poisons the reaction, it slows down the reaction, it stops the reaction. Preparation of sulfuric acid by contact process, in that case, arsenic oxide acts as a catalytic poison. So, we found that there are some cases where promoters are used. Promoter is nothing but, it is not a catalyst, but it catalyzes the catalytic power of a catalyst. For example, in preparation of ammonia by Haber process, N2 plus 3H2 equal to 2NH3. Here iron acts as a catalyst and molybdenum acts as a promoter. So promoter catalyzes the catalytic power of a catalyst. Remember, the transition states, catalyst reacts with the reactants, gets adsorbed on the surface. It is found that more is the surface area, better is the adsorption, better is the catalytic power, better is the reaction. So nanoparticle catalysts are more preferred, smaller size, more surface area and better reaction. So it takes place through adsorption, forms an intermediate compound. And this intermediate compound transition state, it was noticed by a femtochemist, that is Ahamad, who got the Nobel Prize in 1999 for femtochemistry for finding out, tracing out the intermediate transition states in a reaction. So reaction mechanism, when we go through that, we find a transition state, we get an intermediate state. For photocopying this, for getting it, here Ahamad got the Nobel Prize in 1999 and became the father of femtochemistry.